Okay, we're going to get started. For today's seminar, I'm happy to introduce Colleen Peters. She works at the Inner Space Center at URI, and she has a Bachelor of Science in Marine Science and an associate's degree in small vessel operations from Maine Maritime Academy. She recently graduated from URI with a Blue MBA, Master's of Business, a Master's of Oceanography, and she has a certificate in GIS, remote sensing. She at one point was a lead technician on the Falcon and a senior survey technician on the Oceanography Explorer. She's supported over 70 research and exploration expeditions around the world, and her specialty is seafloor mapping, acquisition, processing, and data visualization. And at the Inner Space Center, Colleen assists with a variety of technical and data management projects. So we were very excited to have you here, and thanks.
Great. Thanks for coming, everybody. So my name is Colleen, and I work at the Inner Space Center. Also a contractor for mapping. So I worked on the Nautilus, and I'll be working on the Oceanos again in a little bit of a different role. And I just wanted to make something a little bit more clear. I was asked to come here and present my research, but I just want to note that I don't actually do research in the classical sense. So I'm much more of an operational and technical support person. I put things in the water, I get them back out of the water, manage the data, give people data, that kind of thing. So we're going to talk a little bit more about projects, not sort of classical research. So the first thing I want to do is introduce you guys to the Inner Space Center, in case you're not already aware of who we are and what we do. This is a facility at the University of Rhode Island Graduate School of Oceanography Bay Campus. And we have in our facility three sort of main rooms, if you will. So the first room, the most popular and well-known, is mission control. So in this space, it was designed to host live video from vessels of exploration on a really huge screen, so you could really see everything nice up and close and very high quality. And scientists and students can come here and interact with ships conducting this exploration. So not only can they watch the video, we also have data streams coming in, and they can talk back to the ship via the intercom system. We also support the capability for people from the outside working even more remotely to call into that system, which allows them to talk over the live stream. So if you're watching any of these live streams, you might hear some people do that from time to time to call in on their morning commute or from their office or their home or whatever, and start talking about, you know, what they're seeing on the screen there. So it's a really great way to be able to bring in outside expertise when you can't have all of those people on board. We have a full broadcast studio, so we can do live broadcasts or any other kind of pre or post production filming. And then in our production control, we can do a lot of live broadcasting, much very similar to like a newscasting studio, where you would have someone on site hosting the show, someone out in the field capturing the action, and then splicing in different pre-recorded video content for context and visual excitement. So we can do live broadcasts. We can also do post-production, so filmmaking, anything from small social media pieces all the way to full-length documentaries. So we support much more than just telepresence, and we can do this at various different levels. So the main two partners that we support telepresence with are the NOAA ship Oceanos Explorer with Ocean Exploration Research, and the Nautilus with Ocean Exploration Trust. These two ships have this technology permanently installed into the ship and permanently integrated into all their workflows. So the Oceanos, for example, uses this technology primarily for the science itself. They have fewer berths on the ship for scientists to sail at sea. So the majority of their science participation is from shore, whereas the Nautilus brings a few more scientists. They have a little bit more space, but they also bring a dedicated staff to conduct outreach. So they do a lot more with direct connections to classrooms while they're underway to talk about their explorations. And so we provide the live streaming for these two ships. So this is what allows anybody to connect to these ships' video when they're underway. We also take this technology and we will put it together in a package called the mobile telepresence unit, and we can deliver that to other vessels of opportunity. So these are some examples of those ships. So these are more on a project basis where we have a particular group that wants to do telepresence. They want to just live stream their video feed from an underwater vehicle or some other oceanographic activity, all the way up to full live production. So we can add different layers to all of these projects based on that project's needs, both for science and outreach. So we can start at the very base level where we provide the technology, and then someone from that vessel will operate that technology. We can add the personnel to operate that technology. We can also add people and equipment to document the cruises, to create post-production pieces for further outreach, and then also adding camera people to conduct live broadcasts and the people to host those live broadcasts. So we really cover the whole spectrum of both science and educational outreach from sea through telepresence. So we work with a lot of different groups, and our main three sort of branches, if you will, are telepresence, as I just described, media, so the live interactions as well as post-production, and then also educational programming. So we can bring students to our facility, provide them with an educational presentation about ocean science and technology and exploration on site. We can go to their classrooms and provide a live connection to a ship, or we can connect virtually. And I'm going to talk about one project in particular where we do that. And so we can talk about any topic that that classroom wants to engage with. So if we have a biology class, we'll focus on that. Sometimes we want to talk about technology. So we'll talk about different things that are being developed at the College of Engineering, for example, and can go to really to any topic depending on what they're studying, and also for any age group. So all of these types of broadcasts and programs are tailored to the audience. So we work with a lot of different groups. These are just a few of them. So everything we do is collaborative. So we work really closely with our partners to deliver the product that they are looking for. Sometimes people will come to us not knowing what they're looking for. They want to stream a video feed from a vehicle, but they don't know if they want one video feed, two video feeds, audio. Do you want to have two-way communication? All of these things, tend to be not completely fleshed out when people first come talk to us, but we help walk them through all of the options and try to really hone in on what it is that they're trying to accomplish, both with scientific and educational goals. So we do a lot of projects with vessels of opportunity. So these are NOAA vessels, UNOLS vessels, as well as private vessels. So if you guys want to learn more about the Inner Space Center and these technology or the programming or things that are available for past projects that we've done, you can go to our website, innerspacecenter.org. So now what I'm going to do is talk about a couple of the projects that I've been working on personally at the Inner Space Center. So the first one is a event logging system integration called Sea-Log. This is developed by a guy named Webb Pinner, who has a lot of experience sailing on a variety of vessels and working with basically all of the scientific remotely operated vehicle operators in the science community. So he has really great knowledge on what kind of data is collected, what kind of data people need, how they need to be able to find it, so how it needs to be organized. And so I picked this particular system to integrate into our facility because it's an open source project. So in our industry, a lot of people tend to, at least on the ship side, tend to work in a little bit of a silo. So you'll have somebody in-house who knows how to do a thing, they'll develop a thing, and then that person leaves, and then somebody else has to either figure out the thing or redevelop that thing because they don't know how it works. So I didn't want to end up with a solution that nobody knows how to use. So I wanted to have something that also contributed back to the community. So Any development that we do on this system then goes back to other users of the system and vice versa. Anybody else that develops new capabilities, we can also benefit from that as well. So one of the things that we do is have interns from the University of Rhode Island supporting the NOAA ship Oceanography Explorer. So when the vehicle is in the water, whenever we have ROV cruises, we have watchstanders. So much like you would have on the ship in the control room, somebody standing watch to log data, we have the same thing, but at mission control at the Inner Space Center. And their primary purpose is to make sure that all the streams are running, because as I mentioned, the Oceanos has the majority of their science participation from shore. So we want to make sure that if anybody's experiencing any kind of issue, we solve that really quickly. And so they will stand watch and monitor that, but they're also there to log some other data. So this particular system is used on Jason and Alvin, and then we've now adapted it for a shore-based use, but in a similar way for both the Oceanos and the Nautilus. And so what they'll do is the information that they're trying to capture, they'll enter this into the system. So before we had like 3 different logging mechanisms for different kinds of data, and it was really messy to try to bring it together, try to get to match. Sometimes we didn't always have the right time code. You didn't exactly know who was logging it. So with this kind of system, we have the date and time stamp, UTC, end of story, never changing. We also have everybody's a registered user, so we know who's logging the data. This is put into a database, so it's easily filtered, easily found. And then you can also create templates that outline data that you want, specific data you want to capture. So much like you would have on the vessel, I want to take a sample here. I want a biology sample. I want a rock collection. I saw a thing. Whatever it is that you're trying to capture, you can create a template that gives you drop downs, check boxes, and fields to fill in and make them required so people can't submit that entry without all of that information. And so this can be used, you know, in many different ways. And this is sort of the main screen where you would do that logging. So if I'm on watch, I'll press the ops button. I'll say I checked all the streams. Everything looks good. I had a problem. This was the problem. I'll click the education button. I'll say I saw this whole thing. This should be used for a video. This could be used for a lesson of an adaptation or a geologic feature, whatever the case may be. And then that's captured in that database. So the way that we arrange the data is by field season, by cruise, and by dive. So we not only collect that information that we put into the system through the form, we can also add external documentation like cruise plans, dive plans, schedules, that kind of stuff. So now we have a much more robust system with capturing contextual information as well as the actual data points itself. And there's lots of different ways to review this data. So one of the things we were not previously doing is we record the satellite video as it comes into the facility. But in order to review anything, you have to scrub through like hours and hours of video to find anything. That's really tedious. So we added a frame grab capability to the system. So every time you log a piece of information, it captures a frame from each of the 3 feeds. We also capture the live ROV navigation and sensor data because that's already coming to our facility. And then we're adding all of the information that we want to log on for our own mechanism. So one of the main ways to review this data, and I'm not going to go into every single detail about this as a broad overview. One of the main ways to review the data is through the replay. So you can just literally press the play button and you can just skim through all of the things that were logged during the course of that dive. And it flips through all of the frame grabs, all of the nav data. So you can see, oh, I saw a glass sponge. It was at 2,133 meters. So these are the kinds of questions that people tend to come in the facility and ask. What depth are we at? What depth was that creature discovered at? Where was that located? Well, it's all right here. You can also look at it through the gallery. So if you're just let's say you're an educator and you want to find a really great example of an octopus or some other creature or something that you think you saw in the dive, you don't know what it was. You can just look at this gallery, flip through all the pictures, and just see kind of what was happening during that dive. You can look through just the list of all of the logged information, click on the details for more information. It pops up that window with the frame grabs and the nav data and everything. And all of this data can be filtered through a number of different methods. You can filter by date and time, of course, by person who logged the data, by event value, which are those blue template buttons on the main screen. So if I want to know when the ROV went in and went out every time, I can just pull that up directly. I can also put in a keyword like crab. I want to know all the times that a crab was found. So this makes it a lot easier for anybody downstream to be able to find this data. We also have the map, because as we're collecting that navigation data as the dive is happening, it's easily populated. And then the last point I want to make about the system is that it doesn't only have to be used for dives, for underwater vehicles. It could be used for really any kind of operation that you want to log a thing that happened. You want to know when it happened. You want to know where it happened. And so one of my ideas about how it could be used is for mapping, because a lot of times you have multiple systems running at the same time. And so the Oceanos Explorer, for example, will have different sonars on different streams. And so you could have the ability to capture a frame grab from each of those different systems, but at the same time. Whereas if you were on the ship, you have to log into one machine, you have to take the frame grab, you have to put it somewhere, you have to name it, you know, and you go to the other machine, you got to do it all over again. This is just press the button, boom, there it is, done. And then you add your information that's relevant. And so this would be a really cool way to upgrade some of the logging that I see going on in a variety of ships. Tends to be in Excel. Well, that I think is, of course, very valuable, very useful way to do it, but this could be a really neat way to make it a little bit easier to find the information that you want and really extract that out. So if anybody wants to learn more about the system itself and how it's used out in the field or how it's set up, you can go to the GitHub site and learn more about that and download it and put it to use. So having sailed on the Oceanos, the Falcor, and the Nautilus, who all, in my opinion, my experience, do the most outreach of basically all the vessels in the fleet, I have had a really unique perspective to see how they all do it. And the Nautilus is really great at it. They are, I think, the most successful in making the most connections to classrooms in particular, because they have a staff of people to do this. So they have a bunch of people on the ship dedicated to actually conducting the interactions, as well as people on shore to help coordinate the interactions. It really is quite a big effort to make this happen and to make it happen on that scale. The Falcor, I think, does the next largest amount of connections. They have shore support, but on the ship side, it's a little bit different. They don't have dedicated people to do the outreach. They have to get commitment from the science party to do the outreach. So while they do quite a lot of direct connections, it really is dependent upon the availability of the scientists to go do that. Whereas on Nautilus, people are designated in watches to actually go do this specifically. Now on the Oceanos Explorer, as I mentioned before, most of their scientists are shoreside. They have very few bunks for scientists. So getting the buy-in from the scientists to do it, is more challenging because there's fewer of them on board. Their time is much more needed to actually conduct the operations. So they don't do quite as many of these outreach direct connections to classrooms as the other ships. So I got to thinking about this problem because the Inner Space Center already supports the Oceanos Explorer. We already get their video. We have access to all of their great imagery and content from the ROV. What could we do to maybe help support this and help further the reach of the work that they're doing? So as I mentioned before, we have a full broadcast facility. So we have the ability to not just have a Skype call with a classroom and have somebody, on their laptop with their earbuds plugged in, talking at them about ocean exploration, we can provide a real visual experience about the deep sea. And so the way that we do that is we'll have a host at the Inner Space Center facing the call to the school at the Inner Space Center rather than on the ship, and be able to splice in video content that supplements that conversation. So if we're talking about deep sea biology, we're going to show deep sea biology. And this is not terribly new because we do this on a variety of other ships. Whenever we put an MTU on a ship and plan to do live broadcasting, this is exactly how we set it up. We have the connection initiated from shore because, as we all know, things happen at sea that you can't always prevent. Connections get disrupted, even for things like weather. So despite all of our best intentions to prevent that, it just happens. And so that way, if you lose connectivity to the ship, you're not going to fail on delivering a good program, because the person on shore can just pick the ball right up, keep on rolling, and keep that conversation going, and keep those students engaged for the period that they're doing the show. And when the ship can connect, great, they connect back to the ship. And so if you can just imagine for a second that I come here today and I talk to you about ocean exploration, and I talk to you about the Inner Space Center, you have to decide in your own heads what that even looks like. If I tell you that I saw this really cool discovery that the Oceanos found last year, they were doing a dive, I think it was off of Puerto Rico, where they found a shark embryo. And this was just totally by chance, because they're down there in the deep ocean. It's just this vast area. Somebody sees a coral stalk just sitting in front of the ROV, and they go, what's that thing on that coral right there? So they zoom in, and they keep zooming in, and they find out what it is, and it's a shark embryo. It's just, I mean, this thing is like this big. The fact that they even found this is somewhat of a miracle, right? Because it's a needle in a haystack. So are you guys going to be more likely to remember that I told you about it? Or are you going to be more likely to remember that I showed it to you? So if you think about it in the context of a second grader, a seventh grader, a high schooler, are they going to remember who I am? Probably not. Are they going to remember my name? Probably not. Are they going to remember this cool video they saw of this neat thing at the bottom of the ocean? Yeah, more than likely, right? 38,000 hits on YouTube, yeah, probably. So this is kind of the point of why I encourage people to use the Inner Space Center for some outreach activities from vessels or from shore, because we don't just tell you about ocean exploration, we show it to you. It's a visual storytelling that's really going to engage more students to care about the ocean and want to pursue these careers in STEM. So being able to conduct these interactions from shore allows us to have more flexible scheduling, more flexible staffing, make better use of the facility itself, bring on fun guests to screen, which I like to incorporate our interns into quite frequently. And then also we're not only able to connect to people directly, we can also stream it. We can stream things to video feed, not just to one platform, but to multiple platforms at the same time. So we can do multiple Facebook Lives, multiple YouTube channels, multiple web pages. So you have a much more expanded capability to reach an even wider audience. In addition to that, we can also connect multiple classrooms at the same time, giving them a full screen view of the program with a high quality video, not just somebody on the laptop webcam. So this is a program that we're reviewing at the moment. We connected to a variety of different schools and museums and summer camps. And we're going to hopefully decide in the near future if this is a long-term program that we want to keep running. So I'm going to talk about Ocean Exploration Trust, not just because they're in the building today, but because this is just another project that I'm working on. So underwater video, as probably a lot of you in here know, is an industry-wide problem in terms of managing it, right? We used to think back in the day, oh my gosh, water column data, it's so huge. What are we going to do with it? We have these little tiny, 500 gigabyte hard drives. We're going to need like 1 million, right? Well, that's not so much the case anymore. And multi-beam data really is dwarfed when compared side by side with video data. So we're talking like 16 to 20 terabytes, kind of on average for like a 3-week cruise, just real rough average. And that's a lot harder to deal with. So a lot of the organizations that collect underwater video have their own homegrown method of managing it and distributing it. And it's because there's no one brilliant central solution. This is a problem everybody's been knocking their heads against for a long time. And so the way that OET operates is they have a data request form, so you can request data and it'll get it sent out to you. And that works fairly well, except for the fact that if you don't actually know what you're looking for, it's really hard to pinpoint it because there's no way to review that video. So got to thinking about, okay, what could we do on the limited budget that we had, AKA none, with the resources that we had available. And so at the Inner Space Center, again, another advantage of using this facility is that that video comes to the facility and is recorded directly. So we have a data set during the cruise that nobody else has. So yes, the video goes to Nautilus Live, you can watch it live, that's all great, but then what do? Nothing. If you miss it, you're done, out of luck, until such time as weeks later that video comes ashore and somebody can put it on a drive and ship it and all this thing. So, a month or two later, you can maybe get your hands on it. So what I proposed was working with one of our partners, Vicki Franey at Lamont Doherty Observatory, who's developing a video portal called Ocean Video Lab. And so one of the mechanisms for Ocean Video Lab to be a relatively low budget video portal for the user, for the contributor, is that it ingests video through YouTube. So what I started doing is uploading the satellite recorded video from the Nautilus to a YouTube channel. So we created a separate channel, Nautilus Live Dive Recordings, so that, let's say the day after a dive or a couple hours after the dive, or, let's be honest, Monday, right? The video would get uploaded to YouTube and made publicly available. So now, not only does someone participating in the cruise from the science side have a way to review it, but also, during the cruise, but also if somebody's looking for data, if they know Nautilus went in this region and they did this cruise, it did a thing, now they have somewhere they can go to actually review that video and find out what they really need, and if they really need the raw data for the analysis that they're doing. And so now they can provide more information about what they're requesting. So now maybe they just need a dive, not the whole cruise. If you want the whole cruise, that's like that's a whole RAID system that needs to be, loaded and shipped, and that takes like a week to do. You got to pull it off a tape and get it and ship it. Now if somebody just wants a couple of hours or maybe a dive, that's a Google Drive transfer. That's much simpler, much faster, much more cost effective to actually give you the data. So YouTube here is just really the pass-through mechanism, but it is a way that people can view the data during the course of the cruise. And so the ultimate destination for this project and intents and purposes is Ocean Video Lab. So you go to the portal, you have to be a registered user to do this, but you go to the portal, you connect that video to YouTube. Now, because this is a very manual process, you have to do this for every video file. This is the #1 reason why I don't use the full resolution video, because on the ship, it's broken into 5-minute chunks. This would be a complete data management nightmare. So using the satellite video, we're still able to provide a relatively high quality video. You can still see the things that you need to see, but it's much more manageable because it's in 1 hour intervals, not 5 minutes. So for a 12 or 24-hour dive, this is 12 to 24 files, completely manageable. So we got all the video from this current field season into Ocean Video Lab. And one of the primary goals of this is to make video accessible. So we have all of the Falcor video, all of the Nautilus video from this field season, and an assortment of other videos in the system for viewing. The second part of this project is to help develop an automated mechanism for annotating underwater video. Because although now you go on Nautilus or Oceanography or any of these vessels, they have a logging system to know what's going on, what's happening, where it is, what it's doing. But what if you have all of this older video sitting on the shelf from a dive 25 years ago? You don't exactly know where that information is located. This could be a great tool in the future to be able to automate the process of annotating legacy video where you don't have that access to that data. So as a citizen viewer, so anybody can go to this portal, anybody can log in to be a citizen science user. You can go in and use the simple annotation to help build that algorithm. And these are, you know, fish, octopus, coral, right? Very simple. And if you hover over the buttons in the interface, it'll tell you exactly what it is. People can go in and help build the algorithm by viewing the videos and pressing the buttons. As a registered science user, you can also have the added capability of manually annotating. So, you know, being able to say what the species name is, what's happening, what's going on, what the sample number is, you know, whatever is relevant. And then you can also download all that information after the fact. And for video data that have associated navigation and annotations already available, those can also be ingested into the system. So lots of options here to bring the data together to make it more accessible to the science community and to the public, and being able to incorporate participation from citizen scientists. So if you want to know more about the project, take a look at the portal, start checking it out. You can go to oceanvideolab.org. And a little bit later this year, in the Nautilus off season, we're going to run like not a promotion, but sort of an invitation, I guess, to the Nautilus viewers to help us do exactly this. Go to the site, sign up, and help us build that annotation algorithm. So just to wrap things up really quick, I can't come here and not talk about seafloor mapping. That would be really weird. So I'm gonna do that just to bring it all together. So one of my side gigs, if you will, is as a contractor, as a seafloor mapper. And I just sailed on the Nautilus from Samoa to Canton Island to Baker and Howland Islands to Johnson Atoll, and then finally to Hawaii. And so just kind of going to go through a couple of highlights of what we did. So one of the goals of OET is to help contribute to Seabed 2030 by mapping areas that have not previously been mapped. So on a lot of our very lengthy transits, very lengthy, we tried to map a lot, offset the transits such that we mapped unmapped areas, and also went over some indicated seafloor features to see if they really do exist and what they might look like. So we covered 32,000 square kilometers. Like a lot of data processing, a lot of dots. I killed a lot of dots over the course of that cruise. But we had the opportunity to conduct 3 centralized surveys over features. So this first one was a feature to the northwest of Howland Island in the Baker Howland EZ. So JMRT satellite data here, very roundish looking lump on the seafloor. And we have this magnificent feature with lots of ridges and a little bit of a flat area. Not quite, I don't know if that quite becomes a geo, but a little bit of a flat peak on the top. So this was a pretty neat feature to map. And we did some dives on here. We did a dive on here right along this ridge. I don't know what we did because I took a nap, but you can review the dive on YouTube or Ocean Video Lab. And so we saw, I'm sure we saw biology or something. Cool. This next feature, I think, is like the perfect example of exactly why we have to map the seafloor. I know I don't have to convince anybody here, but in case, the off chance that somebody might be watching this at home, that's like maybe not my mom, you know, this is why we have to map the seafloor, because this is just craziness on the screen right here. We have from NCEI, not to name names, but we have a 22-meter sounding from some really bizarre single beam track. I think somebody was maybe like not operating it very well. I don't really know. Your guess is as good as mine, but that same information shows up on, you know, other resources. So from DMRT, we have, you know, sort of the same information. We have this kind of triangle, sort of blobby thing with this like tremendously high peak. But, you know, then we have this chart overlaid, you know, in the, behind it, which has a very rectangular shape, and the shoal sounding, you guys can't quite see, is 1,298 meters. So it's, we had this great battle between the captain and the ship's crew and the scientists of guessing what the shoal sounding might be. And so, you know, although we didn't necessarily take this 22-meter sounding super seriously, you know, we still took precautions and mapped from deep to shallow to try to get an idea of what this looked like. And frankly, it looks like neither in terms of the depths themselves, but it does have a somewhat triangular shape like the satellite data, so that's kind of fascinating. But it actually has a shoal sounding of 1,291, which is much closer to the chart sounding. I'd really like to know where that data came from and why there's that random 22-meter data, but we'll have to make some corrections there. Again, dive happened. I don't know. I was like sitting outside for 20 minutes, so I don't really know what happened on that dive specifically, but I think we saw cool stuff, as we always do. The last feature that we mapped was in the southeast corner of Johnson Atoll Unit. And so here again, we have some, you know, probably artifacts, tracks going across this feature. Looks pretty elongated, you know, kind of a peak over here somewhere. So we did a north-south direction survey, and it turned out to be a geo with a pretty cool ridge extending from the north. So it's, you know, pretty long feature in total. And we were going to dive on this spot, but unfortunately we were not able to due to weather. So we moved on and ended up diving off of Johnson Atoll. So along the transit, we saw just a bunch of cool stuff. So the satellite data was really useful to find features and necessarily match precisely in terms of the extent or the height or the shape or whatever, but you know, pretty much everyone that we tried to hit along the track, we definitely found a feature there, so that was really useful. And I'm just going to show you some cool biology that we found on the cruise. This is a ceratopsid octopus, and it put on a really nice show for us. Somebody showed me this clip after the cruise. I don't know, cool stuff happened, but yeah, so I sailed as mapping coordinator and just basically did all the mapping, processing, and surveying. So some other people on the ship did all this other stuff, and so you can watch all of the video on YouTube, Ocean Video Lab, highlights on nautiluslive.org, and I'll take some questions.
Is at all different? Is C-Log at all different than JSON Virtual Van?
Yeah, so they have stopped using JSON Virtual Van and integrated all of their legacy data into C-Log now.
It just occurs to me that the obvious thing to do is to merge C-Log with the Ocean Video stuff. Like if, I don't know, when YouTube sends video, if they send actually accurate timestamps of each frame coming across, but it'd be really great to have those integrated so that you see all those notes that were taken in real time in the context of that as you go back through and review.
Yeah, that sounds like a really interesting idea. I think one of our issues with doing it locally at the Inner Space Center is that although we have this recorded data, it only lives where it's recorded for a certain period of time, and then it's sort of archived because we hadn't had a real purpose for it other than archiving it. So without dedicating it to live somewhere, it's certainly possible to integrate that into C-Log, but we would have to like really make a plan around that. But I think that's yeah. So I think that's a really interesting way to think about doing that. Yeah. Yeah. Cool. Thank you. Oh wait, you have to wait for the microphone so my mom can hear you ask the question.
So the outreach stuff, with the octopus is awesome and the baby shark is really cool. And I imagine that, well, you said 38,000 YouTube hits or something. Mm-hmm. Do you have, and it's easy to see that with the biology. It works for my children too, actually. And I guess my question is, do you have similar examples for other types of ocean science, of which there are many, or technology, or ideas for how to do that as well as you can do kind of naturally for the biology?
Yep, absolutely. That's always been something I've fought going on projects at sea. They're like, ROV dives, yeah, biology, yeah, mapping, like, okay guys, can't do your biology thing without the mapping stuff. So just saying. But we do have a lot of animations. So we have like deployments for equipment. We have video deployments for equipment. We have video that we've captured of people doing these things out on these ships. So we do a lot of work with the Endeavor, of course, and we'll often have crew on board to capture a lot of these other operations that happen. We also do a lot of videos specifically about these other deployments, like we have landers and gliders and tows and CTVs and all the things. So we can do that either just by, playing B-roll and narrating that ourselves, or having these, more professionally produced clips made. So we often do have programs that we talk specifically about careers. So we'll get people from the campus, bring them on in and have them talk about their experience out in the field, how they got to where they are, show them video of the technology that they've been developing. So we have a lot of video of like squishy fingers and I don't know what it's called, but like the octo grabber. That's not the name of it, but this thing that grabs the gelatinous creatures will let you film it without squishing it and then releasing it. So we definitely have a lot of content, not just biology. Yep.
A side note, the guy who developed that tool, the
So decahedron. Yeah. Yep. Yep. Yeah. So we'll often, for a lot of these presentations, bring in the expertise from the campus to talk about the things that they are doing. So it's not just our own voices talking about the work in the field. Sorry. Any other questions?
How many different groups have you been talking to as part of
integration of C-Log and bringing this technology together? I know a lot of different groups have been talking about this, and I know a lot of different people I've worked with have been touching on these things, and you need to get those pieces together. You probably have a story of how that happened.
Okay.
About the data.
Yeah. Let's see if I can answer that. So it really sort of starts with coming into the situation, evaluating what's going on. Anytime I start a new place, I just try to observe what's going on and how they do it, and then see if I either know a new answer or know somebody who will know an answer. Because having worked with so many different groups, a lot of folks, and I've sailed with a lot of groups, folks in this room, you just get to know what resources are out in the community. And so thinking about, okay, well, I know somebody that might have the answer or has access to that answer, and bringing them in and working the problem through. So that's kind of how I got started with both C-Log and Ocean Video Lab. And for the underwater video, for example, we hosted a workshop back in 2016 that addressed this specifically. And the result was sort of, we still don't know the answer, but that's why we continue to work on it and working particularly closely with our partners to keep tabs on developments along these threads so that we can be, either assisting them in developing their projects or finding solutions to our own problems that already exist. I hate reinventing the wheel. It's super inefficient. And so anytime that I can collaborate with somebody else to boost up the products or the tools that they're creating or put it to use or test it in a different way, I'd much rather do that.
Thank you.
Great.